What? Oh, there it is. Okay. I really love the way Google does this. Google Docs does this. So when I saw it the last time, it just had this first grouping above Sam, and then in row number 8, somebody had clicked in it um, to start writing, and all it said there was anonymous bat. Oh, maybe it was Sam. Anonymous bat. And I thought this was hysterical. It's like, oh my gosh, we have an anonymous bat here. Like, so weird. So I really, anonymous capybara. I mean, that's just as good as it gets. The only thing that would be better is a platypus. And in a few classes, you'll understand why I say that, but that would be the perfect one. Okay, we're looking at these data, and oh, data is plural, by the way. It's really hard to get in the habit, but if you say data, you should say these data, not this data. This datum, meaning one factoid, one number, is a datum, like here. I don't know why it's not. Oh, I know why, because I'm screen sharing, so nothing I do on there. So that's a datum, that guy, John. But all of it together is data. So these data, I'm going to get that wrong most of the term, but at least I got it right just now. So sorry for the lighting changes. When I shift over here, it gets very dark. Here's what we get to know. We get to know, Elijah, all this is everybody in the class asked, and don't worry, you don't get like marked right or wrong for having done it. We just needed data to work with. Everybody in the class asked 4 people or 5 people on a scale of 1 to 10, what mood are they today? That's it. What mood are they right now? So that's what these numbers are. And I asked everybody to get the person's name and their mood. So for example, Sophie was right in the middle, 5. She's way down here near the bottom on row 23. Oh, there's more too. Okay. Anonymous llama, dragon. These are great. Okay, so we know that Sophie got a 5. So there's usefulness to having these names and numbers paired up together. Imagine that you were working for counseling services and you were worried about how the freshmen were doing and what kind of mood they were in, and see if you're finding anybody who might be has a mood disorder or depressed or something like that. And you could have everybody in the freshman class answer it because they're freshmen and they still do stuff like that when you tell them. And you would get all their moods, and then you go down the list, and anybody who's at 3 or lower, you have a conversation with them, see how they're doing, try to make them feel welcome, double check if anything's going on for them that you can help with. Like right now, Cooper, I'm feeling badly for Cooper down there after Jade, because poor Cooper was in a pretty bad mood. Hey, Jade, how's Cooper?
He's still in a really bad mood.
But
He's
he's
having a
okay.
bad day at work.
Right, see, and this conversation is only possible because we can pair the person's name with their answers. I know I'm talking about something that feels very, very obvious, but I'm going to be comparing it to other things. So if we had the data just like this all the time, and so somebody said, so how's the mood at Elmira College today? The only thing you have is this. The only thing that you could do is say, here, they're like this, and hand them the paper. And they would say, but could you summarize it, please? And you can't summarize well from this. You have to do stuff to it. So one of the very first things that we do with descriptive, even if we aren't actually doing it, we're thinking about it like this, is if we want to summarize, one of the things would be to put them in a kind of an order, right? So I'm guessing if I click on that column and I say, I don't know how I don't work with sheets usually, but I want to sort. No idea how to do that kind of preference. Anybody know this app? It's Google Sheets. I don't see anything. What's this? What's that? I think it's one of these, but I don't know. Nah, this just takes us up and down. No idea. But I'm sure there is a way to sort, pick a column and sort. And so then we would have all of the tens, nines, eights in order, and the names still associated with them. So that would make it easier to find Cooper. All we have to do is go all the way to the top. We organize it by the lowest number at the top, and we find Cooper faster. Imagine if you had to do this for the whole freshman class. You would be happy if you could sort it. That's the first step in organizing. And typically what we do to sort visually is a table. A table like that. Believe it or not, that actually was carefully created by a class from last winter. Now, just look at the first two columns, X and F. In this situation, people didn't do mood. They did something else like the number of siblings, counting yourself, but that, I doubt it's, oh, I know what it was. It was the number of pets. So the first thing we did was what we just did about mood. And then for us, this would be 10, 9, 8, 7, 6. This one, it started up at 8. But on ours, we actually had a scale, 10, 9. And you start with the highest number that's one of the choices. So you get your data, and the first column is X, which stands for the data. And you put the possible number, you put the possible answer 10, then you put below it 9, then 8, all the way down to 1. Now you've got the range of possibilities, and you go back to your spreadsheet. Well, I can see everything. Oh, there we go. You go back here and you count the number of people who got 10, and you put it on that row. And then the number of people who got 9, and you put it on that row. So we're going to do that. We're going to create a frequency distribution table. That's today's job. So to do that, I'm going to use this app here that already has this in it. But I'm going to do it in this semester's notebook so that when students ask me to share it with them, I'll know where to go looking. So this is a frequency distribution table. I would like to be able to rotate the page, but I don't think I can. So what I'm going to do is I'm zooming way in. Okay, so X. Wow. That's not what we're trying to do at all. Okay. X, that's the first. Just hang on. This might be too small. Okay, first column is X, also known as mood. The frequency, F, is the next column, and that's going to be the number of people who had that mood. So we start 10, 9, 8, 7, 6, 5, 4, 3, 2, 1. You guys should be making this table in your notes. And leave some room on the page to, because you saw that there's those other columns, and you're going to want other notes on the page to tell you what they are. So then we go back to the spreadsheet and we figure out how many people got each one of these. So pardon us while we go back and forth here. Any questions so far? Like, unmute yourself and ask them. Okay. So I'll switch to spreadsheet. Now, does anybody answer 10? I don't see any, do you? Anybody see any 10s? Nah, me neither. Count up the number of 9s. Anonymous bat, can you move? Thanks. Hey, anonymous bat, click over here, click like over here someplace. Like go to the blue square somewhere near that, because you're right on top of data. Thanks, perfect. Having fun yet? There you go, back again. You're blocking Grace's answer. Yo, bat, you. Go over here or something like that. Go over here. Go on the same column as capybara. Is bat here today? Who's bat? Everybody check to see if you're anonymous bat. Oh, it's moved. Okay. Don't move again, bat. All right, how many 9s do we have? Unmute if you know the answer and say it.
There's 5.
5, yeah.
I get 2 people who say 5. Anybody think it's a different one? All right, I'll remember 5. How many people said 8?
5.
Anybody else think that's true? So 5 9s, 5 8s, that's all my brain wants to hold on to so far. So I go back over here and I say 0, 5, and 5. All right, how many people said 7?
9.
Agreement? Do I have agreement? Popular answer. That was my answer too, I think. How many people said 6? I see a 4. Anybody else? Come on, everybody look like you're trying to do this, please. Otherwise, we're going to spend all day waiting for numbers off of a
I got 4.
spreadsheet. Get 4, so 2 people got 4. Okay, how many people said 5? 3? Is that what I see? Any others?
Three.
3. And how about 4?
3.
3. How about 3? 1? Oh, poor Cooper, yeah. You'll have to tell Cooper that we really appreciate the use of his name. How many people said 2? Nobody said 2. Anybody say 1? 0 and 0. Okay, so I'm just going to worry about the actual range of responses. Okay, so I am, to make this simpler for us and make sense, I'm just not going to do any further work with those numbers because it'll just take up room on the page and make it harder to see the stuff that actually is happening. All right, so what information do we get from this? Imagine that this is the only information you got, that nobody showed you the spreadsheet with the names and the numbers. That all you have is the possible answers from the highest one down to the lowest one and how many people got each. The first rule of a frequency distribution table is that you always start with the highest number. Just think of it as going down, which means the numbers should be going down, right? As you move down, The numbers should be higher at the top and you're going down to the lower numbers. For some reason, some students get that backwards. What happened? Suddenly I'm in the wrong notebook. And the notebook I wanted to use is not here. Unbelievable. Because I expand, zoomed in, look at that. Isn't that lovely? Some of our problems involve so many steps that I have to do that a lot, and then I try to do a screenshot of it. Okay, so here you can get some things easily, but some things not at all. Like if I ask you now, what was Cooper's answer? We know that Cooper's answer was a 3 because we've been talking about it, but if all you got was this, you would have no idea what Cooper's answers were, what Sam's answer was, anybody's. But you could do this. What was the most common response? What was it?
7.
Yep, 7, 9 people. So it's what you have to remember is what's in each column, because it's very easy. See all of these single digit numbers, right? So it's easy to forget what's in each column. Just remember the first column is the data. It's always the data because that's what you're doing stuff to. The second column is always the frequency of the data responses. So the second column is how many people said that answer or did that thing. And I'm going to just erase the ones that I'm not using so that I give you an easy page to look at. Okay, so often what we do is we get a total. So that's a symbol for all of, the sum of. So count this up and tell me what you get. Somebody tell us what we've got.
I think it's 30.
So do I. I think it's 30 also. Okay, so we have 30 people. This number is going to help us later with the other columns. Okay, the next column is RF, which stands for relative frequency. What we're going to do is we're going to find out basically what proportion of responses said 9. It's like percentage, but it's expressed as a decimal. Our next column after that will be percentage. Nah, we'll leave percentage till later. I'm trying to think of the order to put them in that are easy for you to see how to do it. Not necessarily the order that always shows up when you see one of these tables. The columns get put in the order that makes the most sense for that project. All right, so relative frequency is what proportion of people said that answer, and it's not that hard to get, especially if you have a nice round number. For what proportion of people said 9, we're going to put the answer 5 people over the total 30. So for that one, it's 5 over 30 equals what's the decimal for that? Now would be a good time for calculators. You're
0.16 repeating.
1.6 repeating. Anybody else? Okay, now's a good time to talk about.
Yeah.
Great. Now's a good time to talk about rounding. We're rounding to the hundredth. So 0.16666 repeating. Okay, we're always going to put all of our numbers just the first two decimals. So what we need to do is figure out whether that should be a 6 or a 7. In this case, the number that comes after it is 6. If the rule for this class will be we round to the hundredths, and if the one in the next place, which is called the thousandths, if that number is 5 or above, no matter what the one in the hundredths is, if this next number, this 6 right here, oh shoot, well that's not going to work. I'll point to it, hang on. If this number right here is 5 or above, then the answer that we're going to end up using and writing is 0.17. I know my handwriting's terrible. I try my best, but it's hard to do with this pencil on an iPad. It's slippery. And I have a neurological disorder that makes me have a tiny, tiny tremor. So it's a mess to write. Okay, so what we're going to put for the relative frequency is 0.17. And the next one now, we know the answer already because it's the same question. What is 5 over 30? Okay. Now, what's 9 divided by 30 for the next one? I'm going to start picking people by name if I don't get more variety of responders. So be ready. In fact, I'm just going to call people by name anyway. 9 over 30? Elijah, were you?
Yeah, it's 0.3.
Okay, 0.30?
Yeah.
Okay, anybody else get that? Okay, 0.30. Who wants to do the next one? 4 over 30. If you haven't answered yet, then you do. Waiting.
0.13.
Thanks, Sam.
No problem.
Well, Isaac is right there. Tell him he can do the next one. Does he have a calculator?
0.1.
0.1? 0.10, Isaac?
Yes.
Okay, so we can get 2 of them at 0.10. Anybody else get the same answer? Forgot to check. Yeah, I see nodding. Okay, and then finally 1. Somebody who has an
0.03.
0.03. Okay. So let's add them up, see what we get. Anybody else get that exactly? 1.00?
Yeah, I got it.
We got lucky because it never comes out to be perfect, but we just happen to get lucky. It's going to make you like your notes better. So the summation of the relative frequencies is 1.00. And if you think about that as percentages, all you have to do is multiply it times 100. And you get 100%. So what you're learning is that you have 100% of your responses are included in that column. And that's how you know that you've got your numbers down correctly. Okay, so the next column, we might as well do percentage because we just talked about it. So percentage. All you have to do is take all of the relative frequencies and multiply each one times 100. So 17, 17, 30, 13, 10, 10, and 3. And when you add them up, 100%. Who's lost? Who wants something explained? You have to tell me, you have to speak up, because since I'm doing screen sharing, I can't really see names, and a couple of you at least are showing me your ceilings and what's on top of your head and all that kind of stuff. All right, who, let me ask one more time. You have to speak up. Who is a little bit lost? Come on, there's always somebody. We're here to help. Okay, you're not lost. The next column is cumulative frequency. Cumulative frequency is attempting to find out how many people scored up to a certain answer. Oh, sorry. So how many people's mood was 5 or below, for example? That kind of a question. So cumulative frequency, the way to do it is to start at the bottom. I don't know why that keeps shrinking down there. Hold on. You can't really work with it when it's like that, though. So how many people scored up to a certain score means you have to start at the bottom and add. So we're taking the frequency column and we're adding from the bottom up. So one person scored a 3. How many people scored a 3 or a 4? 4 people. How many people scored a 3, 4, or a 5? I add another 3 and I get 7 people. You see where I'm going with this? How many people scored 6 or below? 11. I added the 4 for that 4 people answering 6, and I added them up. I'm sorry, but my rows are not lined up very well, so let me just do this. And if you have in your notes, you might as well go ahead and draw the lines in between so you can see if you need to. How many people scored 7 or below? I'm adding 9, so we have 20. How many people scored 8 or below? We have 5, so 25. And then how many people scored 9 or below? 30. So notice that that 30 matches that 30. That's a check on your table that tells you you did the column correctly. And then we sort of go crazy and use a lot of other columns. The thing is, not all of Psych uses these frequency distribution tables, and those who do don't use all of the columns. but at various times, you'll see some of the columns. Or you'll need to think about something like that. For your job, for your life. It comes up. I have it come up in casual conversation, believe it or not. Back before the pandemic, I would sit and have lunch with Robin O'Brien, and she would say, hey, how many people are not going to pass your stats class? Or she'd say, how many people have below a C in your stats class? Something like that. That would require me to go quickly to the table, look and say, oh, 2. By the way, I don't expect that to happen this term, but basically you're using a frequency table. A grade sheet that I do in Excel will sort by the grade column. Done. Okay. The next thing that we often see is cumulative relative frequency. Let me continue making these lines so that I have a better shot at not confusing you with the answers. Okay, so cumulative relative frequency, it's a lot like cumulative frequency. You just find the relative frequency column. I just changed the color. And you add up from the bottom what frequency people had. So how many people scored, what proportion of people scored a 3? It's 0.03. How many people scored a 4 or a 3? You add 0.1 and 0.03. Who's lost here? Who doesn't know what I'm doing and how I'm getting it? So you can all follow along, even though I'm not drawing all kinds of stuff to show you how I got it. Okay. How many people got a 5 or below? You add another 0.1, so 0.23. And then you keep going up. How many people got a 6 or below? You add another 0.13, so 0.36. You add 0.3 to that, so 0.66. You add another 0.17 and you get, oh, that's a good one. Is it 0.83? Yeah. And then you add another 0.17 and you get 1.00. So cumulative relative frequency, those are the numbers that match, the green ones. Let me go back to this one for a second and do this so you can see what matches with what. And then you could do cumulative percentage. Let's do it just because. All right. I'm hoping you could follow that one. It's done the same way that cumulative frequency, cumulative relative frequency are done. Hold on a second. Let me switch back to this one to see if there's any other columns that we need to worry about. No, that's good enough. Okay, so that's what a frequency distribution table looks like. They look like a waste of time. It looks like a lot of fuss and bother for not that much information that you can actually use to analyze problems, but they're used a lot by people in ways that you wouldn't expect so much. But the people who use it the most are educational psychologists, personality psychologists who are trying to figure out what proportion of people are like this, what proportion of people got this grade, what proportion of people are this personality type. So they use tables a lot. The kind of tables that you see in articles are not usually this kind of table. You don't usually see anybody writing anything down about cumulative relative frequency. Like that just doesn't come up a lot. But every psych major learns it, so by golly, you're learning it. The idea is whatever the grad schools expect you to know, that's what we make sure is in the course. And that way you're speaking the same language with other people who've graduated with the major. That's the bottom line. So now let me hear any questions you might have about a frequency distribution table. Before you do that, here would be your goal. I would give you some numbers, like a set of numbers that don't mean much. It's just made up. And you would create a frequency distribution table and be able to do all of these columns. And I may not use all these columns. What I like to do is set it up so that each column is worth a certain number of points. And sometimes I use only 4 columns. Sometimes I put in 5 columns. Well, here's how you can, here's where you get a point for the first column. Would be you started with the 9 at the top or the 10 at the top rather than the 1. The second column is all about accuracy. From then on, it's all about accuracy. Okay, now, any questions about frequency distribution tables? Do you want to try another one? Yeah. I'll set you up with some practice problems. And then you can see what you think. Okay. So that's one way of organizing data. This is part of descriptive statistics, right? Basically, it's about describing and organizing. That's actually got a lot more useful information in it than, say, this. But you lose a lot. Like you don't know who says what. And if we had been keeping better track, it looks like almost all of you used yourself. So not only do we lose who they are, but we lose who collected their data. But you gain a great deal. You gain the most common answer, the highest answer, the lowest answer. Where's the bottom? What's the bottom 2/3? What answer separates the top third from the bottom 2/3? Because let's say that you want to take the top third and have them be in charge of the parties. I know no parties, but you know what I mean. And the answer to that happens to be number 7. Number 7 is the split between the top third and the bottom third. Take a look and raise your hand if you don't see how I got that. Because that's actually not necessarily obvious. You don't see? You don't see? Okay, look at, I'm trying to figure out where the top third and the bottom third separate. So 66% below, right? And everybody above is the top third. And if you look for 66%, basically what you're looking at is the number 66 in the cumulative percentage, the last column we did. So you take that and you go across and you find out what X is, and X is 7. So the answer is 7. The score of 7 separates out the top third from the others. I just picked thirds because I saw that 6-6 and I jumped on it to explain something. Okay. I think they're pretty self-evident. They're just a pain in the neck to remember what to do for each column. Just remember all the ones that are cumulative, you start at the bottom and add up to the top. And you should have indicators in these columns that help you know that you got the right answer. So when you do relative frequency and you get 1, cumulative relative frequency should give you 1 at the top, because you're adding up all the relative frequencies. So you should get the same number whether you add them from the top down or the bottom up. And the same thing's true with all the cumulative ones. You're adding up all the answers. So you should have the same number if you put a summation at the bottom as whatever your top answer is with the cumulatives. All right, it's very weird not to be in a room. In a room, I can see much better who's lost, but I'm going to trust you to speak up if you're lost. Here's the deal. We're a small group. It's easy to say on schedule according to the syllabus. And if you don't speak up, we can't stop to help you, but we will help you, because there's going to be, for every one of you who speaks up, there's going to be 2 of you who should have spoken up. So help out other people by saying, I need help figuring out what you just did in that second column or something like that. All right, so last chance. Anybody? It's the most boring thing in the course, so we're done. Hooray, hooray. Now we're going to do something that's less boring. It's actually what the part that when you were a kid you liked the best, graphs. People like graphs. They get to draw pictures. They get to use different color pens. It's fun. We're going to graph these data. So we're going to create a graph of people's mood yesterday. And in order to do that, first you have to learn the rules of graphing. So the way that I grade graphs is I grade them first for accuracy, like are the lines, are the columns correct? And then whether or not you follow the rules of graphing. So first rule is called the 3/4 rule. The 3/4 rule, the y-axis is 3/4 the length of the x-axis. Oh, goodness, I do that a lot.
Can you say that again, by any chance?
Yeah, the y-axis is 3/4 the length of the x-axis. For those of you who are trying to see the screen, does it look like a list, like a column of your faces is blocking part of that graph? All right, I'm just going to have to move it. I'm going to draw it again because it's just me and it's not working. So I'll put it here.
You could move our faces to a different part of your screen.
Yeah, but with share my screen, I've got the iPad screen covering the whole thing. So there's really no place to move you. I just have to move the work. Okay, so that's approximately 3/4. Just remember to make a rectangle that looks close to a square with the long side going horizontally. So 3/4 rule, that's one thing. You have to label your axes. In a frequency distribution graph of any sort, bars, lines, the frequency is the y column, the y axis. And the data, whatever it is you're collecting data about, is the x-axis. Don't put x and y as your answers here. So In this one, we're going to put mood. And you want to use the full ranges of your frequency and the full ranges of your mood. What I mean by that is, oh wait, let me do this, label axes. And then F is y-axis. Anybody remember the names, the word names for the X and Y axes? Was anybody a math geek? The y-axis is always called the ordinate axis, and the x-axis is called the abscissa. And the only reason I know that was because I loved words, and abscissa is a really cool word. It sounds weird when you say it, so I liked it. I remembered it. I've never had to use that information in any way, but it sounds good, abscissa. Okay, so what I mean by using the full range is this. I've drawn the axes in a 3/4-ish way, and our lowest possible score was a 1, so I'll put it right there. And our top possible score was a 10. Something like that. Something like that. Sort of evenly distributed. I mean, I'm working on a blank page. I could have pulled out one that's made for graphing, but then I'd have the whole course with those lines everywhere, and you would get really tired of that. I've been there. I've done that. Okay, and then it's very important to use the entire y-axis. It's really easy to get to not do it. So to know what to put in the y-axis, the axis goes like this. You always start with a 0. Always, always, always start with a 0. So what if we collected data out of a ton of people and the lowest number we had was 50? Do I really have to go 0, 1, 2, 3, 4, 5, 6, all the way up to 50 and nobody's there? Like we wouldn't normally need that because nobody answered that. There's a way around that. So here's the y-axis and here's the x-axis, and just pretend that it's the right, all right, fine. Hang on. Okay. You want to start with 0, but your lowest number, say, is, let's call it 100. You put the 0, and then you indicate that there's a break before the first real data. And there's a couple ways to do it. One way is just to go like this. I'm just going to enlarge that. So we've got looks like that. Or sometimes it looks like that with the line going through it. Or sometimes it looks like that with a zigzaggy line going through it. And other times it looks like that with just the zigzag. It's called a broken axis, and you use it to indicate your lowest number. Now, why do we put a 0 there? Honestly, tradition. It's dumb. I think it's dumb. I've never actually looked at a graph and said, oh, thank God for that 0. Otherwise, I wouldn't know what I was looking at. I've never had that experience. And I am 65 years old and been doing this for 3/4 of my life, and I have never seen that. But I see the broken axis every time. I've never seen one that used up a bunch of the, except for students, never seen somebody use up all of the space with numbers that we're not using. This case, that's not a problem, but I wanted to tell you about that rule. So hold on while I do this. So that's one rule, two rules, third rule, a 0 on y-axis required. Sorry, my medication never kicked in today. I think I'm gonna have to start getting up early and taking it earlier, since I'm usually up an hour before I am teaching from home, and I think by then my writing is always a little better. But between the slippery screen and this disorder, it's not so good. I apologize for that. Not that I have a lot of control, but okay, so 0 required. So we have a 0. And in this case, we don't have to break the axis because our numbers are all down under 10. Right? So we're looking at our frequency column, this first yellow column. Our lowest number is 1. Our highest number is 9. So we, using a whole axis, we put a 9 there. And then you evenly distribute the numbers 1 through 9. So that's not bad. So X, mood, is across the x-axis, the horizontal, and the number of people who have that mood frequency is in the vertical. And then we're going to create what's called a histogram. It's just another name for a line graph. We're going to start, let's start at the top because it's easy to start at the table and work down. So, oh no, we have to start at the bottom because it's easier to work left to right. So we're looking at mood of 1. Nobody had it. Mood of 2. Nobody had it. Finally, Cooper can shine again. A mood of 3. I know. I can't wait to meet Cooper someday and ask if he's okay. Tell him your professor wants to make sure he's okay. That you have
Really
told you to
will.
double check and make sure he's okay today.
I will.
Good, good. That's awesome. Okay, so one person said 3. So you go over to the mood of 3 and you go up to 1 and you put a dot. Don't you love graphing? What grade do you think you're in right now? Is it 5th or 3rd? It's one of them. I love graphing. And then how many people said 4? Their mood is 4. 3 people said that. So you go over to 4 and you put a dot up where it says 3. And you keep going. 5 people said, no, I'm sorry, 3 people said 5. So we put a dot there. Every once in a while, a student will do a graph in reverse. So just remember which thing you're putting where. Like, don't reverse mood number with frequency number. It's really easy to do. You just heard me do it. Whose mood was 6? How many people? 4. Whose mood was 7? 9. Way up there. Whose mood was 8? 5. Whose mood was 9? 5. You know, I don't think I drew this 5 in a good spot. And whose mood was 9? 5. But nobody had 10. Okay, we're not done. Now we're going to draw a line from one to another. I'm wondering if I can actually, yeah, I can. Hang on. I want to be able to do this, do something else to this in a little while. Elsewhere. So I'm gonna, can I copy it? All right, good. I'll get back to that later. So now back to the one that we're working on. We're going to connect the dots from left to right. Don't skip any. And yours should look about like that. And that's a line graph of the data. Now, a frequency distribution table is really boring, and that 0.30 or 30 doesn't strike us as interesting. But look at the graph. Doesn't something stand out? Doesn't that number 7 really jump out at you? Like, gosh, a lot of people have the mood 7. This one right here. You can see which is the most popular response. By the way, when we get to it, that's called the mode, the highest response, the highest frequency. And I'm going to be covering mean, median, and mode soon. Okay, there's other ways to do this with pie charts, which we won't be using. Very rarely see them in journal articles. This is the kind of graph you see the most of, but the other kind that you see a lot looks like this. Instead of drawing a line graph, they're drawing bars. So basically you draw a bar that's left side is between 2 and 3, and its right side is between 3 and 4, and it goes up as high as that dot. So it goes like this. And then the next line goes up as high as the next spot. Actually, we can go across too, like that, because they were the same answer. And then the next line goes up to that dot, over across to halfway. Yeah, I didn't draw the lines very well. Didn't draw the dots very well. Pretend that dot is in the halfway point. Pretend it's right there. Like that. It's a very ugly but accurate bar graph. Sometimes you'll see them with the bars separated by a little bit of space. That's got a name that's different from whatever the name is for this one. It doesn't matter. I'm just letting you know how these graphs are created. My expectation is that if I gave you some data, either just a list of numbers or a frequency table, that you could draw a line graph from it. So a typical kind of a quiz or answer questions on an exam have been, I give you a bunch of numbers and you create a certain number of tables. Where'd it go? It's on this page. No, it's not. Oh my God. Here. I give you a bunch of numbers and you can create the table and the graph. That would make a good quiz. And I'm thinking for this class, instead of having 3 big exams, we just do quizzes from every topic. That way I can drop your lowest quizzes and your grade gets a bigger boost that way than it would if I put like extra credit questions on exams. And your grades will be higher than if you do 3 big exams, because quiz grades are always higher in this class than exam grades. Does that sound good? Yeah. Anything, I mean, all I have to do is assess whether you learned it. I don't need to assess whether you learned it and remembered it for the 4 weeks. till the next exam. Do you know what I mean? I want you to be exposed to this stuff and have a sense of how it's accomplished so that if you have to accomplish it in the future, it will be familiar to you. Not that you're going to remember 5 years from now exactly how to come up with the cumulative relative frequency column for your volunteer job, for your child's school or something like that, right? It's not important that you memorize how to do all of this for long term. You just need to be exposed to it and be able to think about what it is. And then you can always refresh yourself on how to create it. All you have to do is go to YouTube and say frequency distribution, and you'll see plenty more columns than this. And they'll tell you some other way to create it. So no sense getting too particular. But a quiz, that makes sense. And this is what we call just ways to demonstrate the data, just ways to organize it and share it without doing any math yet, really, except those columns are a little bit of math. This is what you do when you want to be able to show people the whole distribution. That's not what we usually do. Usually we say, what's the average mood for the day, right? What's the average? What's the mean? How far away from that mean were most people? If you want to describe a group of people, usually the question is like, say, how did your students do on the test? Or how did your team do on the confidence score? On the self-confidence score? Or the, how did your students in your major or your friends in a club do on the self-identity score? The diversity group could do a really nice kind of a set of frequency distributions and graphs, but nobody cares about that. What people would really want to know is, what's the average for that? What's one number you can just use to describe this? What one number? If you go all of these numbers and all of these people, what's one number you could use? Now, this is interesting because here we knew who had what mood. That's useful if you want to work with individuals. But then we go to how many people have what mood. We have lost the personal. But we've gained a great deal of information and efficiency, actually. Once somebody makes this, using it is pretty efficient compared to using all the numbers in whatever order. And we also get a fast way to answer questions like, what's the most common mood? 7. Graphs do that fast for you. But what does it better? Actually coming up with the answers to the questions, what's the mean? What's the median? What's the mode? Oh, I thought she was coming in to tell me not to be so loud. Lee Ellen is my partner is in a meeting in the next room. All right, so we're going to cover what we call measures of